Hi friends, today we discuss the existing conditions of Fourier transform, Laplace transform and jet transform of a time domain sequence. So, in order to check the existing condition of Fourier transform, first of all we should know how can we evaluate the Fourier transform of one time domain signal. That is, we can write that as x of omega is equal to integral or entire time interval means minus infinite to infinite x of t into e power minus j omega t dt. Now, the existence of this Fourier transform of time domain sequence means the magnitude of the Fourier transform must be a finite value, means the magnitude of x of omega must be less than infinite. So, already x of omega is nothing but this integration. So, the magnitude of this integration must also be finite, means integral mod x of t into mod e power minus j omega t dt must be finite. And as we know, e power minus j omega t is cos omega t minus j sin omega t and its magnitude is 1. So, if it is 1 means the left out term is integral minus infinite to infinite mod x of t dt must be finite value. That means whatever the area covered by the time domain function itself is finite, then its Fourier transform will also be existing. This is the existing condition for the Fourier transform. Like that, if we take the Laplace transform of a time domain function, we can get x of s is equal to integral minus infinite to infinite x of t into e power minus st dt, where s is the independent variable in the frequency domain and s is complex in nature, that is s is equal to sigma plus j omega. When we substitute s value in this x of s, we get integral minus infinite to infinite x of t into e power minus sigma t into e power minus j omega t dt. And in order to get the existing condition of x of s, here also the magnitude of x of s must be finite, means less than infinite. For this, x of s can be replaced by this entire integration here. So, integral minus infinite to infinite mod x of t into mod e power minus sigma t into e power minus j omega t dt must be finite value here. So, here also the magnitude of e power minus j omega t is 1. And now the left out term is integral minus infinite to infinite mod x of t into e power minus sigma t dt is less than infinite. So, here the x of s value, the magnitude of x of s is depending on the magnitude of x of t as well as the value of sigma, where sigma is the real part of s here. That means even though the area covered by this x of t is finite value, the existence condition of x of s is also depending on the sigma, means real value of s. So, this real value of s can be located or can be designated in the s plane. If it is considered as s plane, this is the real axis and this is the imaginary axis. So, on the x axis, based on the values of sigma only, we can decide the existence of the x of s. So, that is why in this Laplace transform we get the concept ROC, which is nothing but region of convergence. Region of convergence can be defined as region in the s plane at which the magnitude of the Laplace transform of time domain function is existing, or in simple we can say the values of s for which x of s will exist. The same ROC concept is not there in the Fourier transform of x of t. Why? Because here the basic thing, the general thing or the mandatory thing is the time domain function x of t must be finite, and this condition is satisfied in the Fourier transform. So, that is why there is no ROC. If this condition is satisfied, everywhere the Fourier transform will be existing, but here that is not the case. Even though x of t is satisfying the condition, the Laplace transform of x of t is also depending on the sigma. So, for only few values of sigma only it will be existing, that is called region of convergence. And the same thing is also applicable for the Z transforms. If we have the Z transform formula, we can write that x of z is equal to sigma n equals to, if it is unilateral and right sided, it may be 0 to infinite. If it is bilateral, means minus infinite to infinite, we can write. I am considering unilateral here, and x of n into z power minus n. Here also the magnitude of x of z is finite, then we can say the Z transform of time domain sequence is existing or converged. That means sigma n equals to 0 to infinite, and the magnitude of x of n into magnitude of z power minus n must be finite here. So here also the time domain sequence must be finite, as well as the magnitude of z power minus n must be finite, and z is also complex independent variable in the frequency domain, and it can be considered as mod z into e power j theta, where mod z is the magnitude of z and theta is the angle of the z here. So when we substitute this one along with this x of n, the existence condition of x of z is also depending on the magnitude of independent variable. So here also in the z plane, when we draw the z plane here, this is the real axis and this is the imaginary axis. Magnitude of z means that will have the real part as well as the imaginary part. If z is equal to, the magnitude of z is equal to 1, then we can have the 1 here, and we will draw a circle by making the 1 as its radius. So based on the value of z and based on the condition of that region of convergence, we can say it will be existing within the unit circle or on the unit circle or outside the unit circle. So this is also ROC in the concept here. Why? Because in the Z transforms also we got the ROC, means here also the time domain sequence x of n, even though it is finite, but the existence condition of x of z is also depending on the independent variable in the frequency domain. So for very few values of z only, it will be existing in the z plane. So this is the difference among these three transformations, where we don't have the ROC in the Fourier transform, we will have the ROC in the S plane, means for Laplace transform and Z transform. And the imaginary axis of the S plane can be mapped to the circumference of the unit circle in the Z plane, and the left half of the S plane can be mapped to the interior of the unit circle here, and the right half of the S plane can be mapped to the exterior of the unit circle. And this relation between the S and Z is very important in the design of digital filters. Thank you.